So using this in particular, this last rule, we can prove that we have that the derivative of f ex is the same, right? Ex. Now if we have f minus prime, sorry, f minus 1 of x is the logarithm, right? What's the derivative of the logarithm? Okay, the derivative of the logarithm is 1 over f prime, which is ex, right? So it's the derivative of ex, evaluated at f minus 1, okay? So e to the logarithm of x. E to the logarithm of x is 1 over x. So this is the derivative of the logarithm, okay? Could also be the case that we, instead of thinking about the logarithm, the natural logarithm, we have our let's say the logarithm in base a, right? Which is let's call it the inverse of our function f a to the x. Okay. So now what's the derivative of this function? Well, as usual, we can write this like this: e to the x logarithm of a, and now the derivative. Okay, and then this is using the chain rule, right? This is e to the x composed with this is e to the x composed with x logarithm of a, right? This is what it is. And so the derivative of this is going to be e to the x, the derivative of this, but evaluated at this function, so e to the x logarithm of a, or in other words, a to the x, times the derivative of this, but the derivative of this is going to be the logarithm of a. Okay, so in other words, the logarithm of a times a to the x. Okay, so now we have the derivative of the logarithm of x in base a, okay, is 1 over this derivative, but evaluated at the inverse. Okay, so this is a to the log a of x times the logarithm of a, right? Now this thing is x because it's the same function, so this is 1 over x logarithm of a. Okay. Now let's see a couple more. Using the same thing, we have function f is x to the alpha, where alpha is any real number. Okay, we have seen that x to the n, when n is natural, the derivative of f, if alpha is natural here, would be alpha x to the alpha minus 1. Okay, now we're going to see that this is also true if alpha is a real number. Okay, again, we can write f as e to the alpha logarithm of x. Now f prime, applying the chain rule, this is going to be, this is ex, right, composed with alpha logarithm of x. So the derivative of this is going to be the derivative of the exponential composed with this to the times the derivative of this, which is alpha divided by x, right? Now again, this is equal to x to the alpha times alpha divided by x, or in other words, alpha times x to the alpha minus 1, okay, which is the derivative that we were searching for. Okay, and finally, let's do one of those trigonometric ones. Okay, so we know that the inverse of the sine, right, is the arc sine. We call it like that. What is the derivative of the arc sine? Well, the derivative is 1 over f prime, which is the cosine of x, right? The cosine, but evaluated at the inverse, okay? Instead of the cosine of x, the cosine of the arc sine of x, right? Now, how do we express this in an easier way? Well, we know that the cosine of x is the square root of 1 minus the sine squared. Okay, so then this is equal to 1 over the square root of 1 minus, and then the sine squared of the sine of x, but this is the same as x squared. So the derivative of the arcsine is 1 over the square root of 1 minus x squared. Okay. Now, using the same technique that we have been using, you can compute the derivative of the tangent and the arctangent. Okay. For the tangent, you need the derivative of the quotient, and the arctangent once you have the derivative of the tangent, right? And finally, this is a table of the derivatives that you need to know. Okay, some of them we have proved already: the derivative of the constant, x to the alpha, e to the x, and a to the x, the logarithms, the trigonometric functions, the tangent and the cotangent. You can prove on your own. The arcsine, we have seen the arccosine, you can prove as well. The arctangent, arccotangent, you can prove. The derivative of the hyperbolic sine and cosine are just derivative of exponentials, right? So it's easy to see them. And the same with the hyperbolic tangent and cotangent using the quotient rule. Okay, so these are the derivatives that you need to remember.